engineering drawing, the important chapter is scale. Okay, we have to start the uh, theory portion of the scale. Okay, from basic we have to start the chapter scale. It's very useful for the engineering drawing for both BTech, diploma, and also the examination ATO syllabus. Okay, so up to this, what is scale? So what is the definition of scale? Okay, so scale is a device which is used to measure any size of the object. Okay, so that the definition. Scale is a device which is used to measure any size of the object. Okay, so in technical drawing, the purpose of construction of the scale is to reduce or enlarge the size of the object without manipulating its shape. Okay, so in drawing, the purpose of construction of scale is to reduce or enlarge the size of the object without manipulating its shape. So the very important term is to reduce or enlarge the size of the object without manipulating the shape. Okay, so next is to understand the scale, 6 parameters must be necessary. The following 6 parameters, in which first one is representative factor, which is also called as RF. So we have to understand what is representative factor. Okay, 6 parameter. The next place, right? Okay, to understand the scale, 6 parameters must be necessary. Okay, next, first one is representative factor. So in short form, we can write RF. Okay, this R, and so representative factor is, the definition is which is equal to length on or of drawing divided by actual length of object. Okay, so before starting the representative factor definition, we have to discuss some example. So if you have to drawing a object like the image of the or the plan design of the uh, house or apartment, so the house is much bigger than the our drawing sheet. Okay, so the let us take the length of the house, which is equal to, let's it may be 15 feet. Okay, so and we have the drawing sheet length will be, let's say, 3 feet. So we can't draw the picture or the length diagram in drawing sheets. Okay, so we have to multiply some factor, let's some factor, so that we can fit in this drawing sheet. Okay, this factor is called as array factor. In short form, this factor is called as array, and which is equal to 3 feet. That means the drawing sheet length. Okay, this is drawing length divided by, and the length of the house is 15 feet. That means actual length. This is our actual, and this is, we have to reduce the drawing of the object. Okay, next example, this is example 1, and next example 2, we have to draw the dimension or the dia of the gear in our wristwatch. Okay, let's we know the gear size will be very small, and we have to for this drawing we have to zoom the drawing. Okay, so let's its dia will be 3 mm. Okay, and we have to make the drawing sheet, and that means the drawing dia will be, we have to make it 30 mm. Okay, so we have to multiply some factor in the actual length of the dia, so that we can zoom it. Okay, so we have to multiply 3 into 10, which is equal to 30 mm. Okay, this 10 is called as representative factor, and this may be greater than 1, this may be less than 1. Here the representative factor is 1 by 5. Okay, this is 1 by 5, 15 into 1 5 is equal to 3 by, and this is representative factor, this case is 10, this is greater than 1. So in this case, and this is less than 1, this is called a reducing scale, as the representative factor is used for reducing the object where the actual image is greater than the drawing work. Okay, next example is enlarging image. That means the actual length is very small, so that we can multiply some factor to reduce, sorry, to increase the object. So in this case the scale is used called as enlarging scale, and our normal scale is full scale. That means no enlarging, no reducing. Here the actual image and the drawing object will be equal. Okay, so this is our first factor. This is called representative factor. Okay, if any doubt you can comment. Okay, so that I can clarify more better. Okay, next parameter, which is called Next parameter is called second number, is called sizes. So it is further divided into three parts. One is called full size scale, and where full size scale, as I discussed the from above factor called rf, rf is equal to 1. Okay, next size scale is a reducing scale. Okay, where rf will be less than 1. Okay, as I discussed previous case, where the building plan will be reduces as the actual image is not fitted in the drawing sheet, so we have to multiply some factor, this called representing factor, which will be less than 1. Okay, next our size scale is enlarging scale, where representing factor is greater than 1. Okay, these all are examples I have discussed in the first representing factor example. Okay, next our will be what are the types parameter. Okay, the types will be 5 types. Okay, first one is plane scale. Second, B will be diagonal scale, and next is vernier scale. Next type is comparative scale. Next, number 5 will be scale of chords. Okay, this plane scale and diagonal scale will be discussed next. Our next after scale is over, we have to discuss this vernier and comparative scale. Okay, next our type is units. Okay, some important units we have to remember, or this is very much logical, you don't have to remember. Okay, for linear measurement, you have to see this mm, centimeter, decameter, decimeter, meter. Okay, decameter, hectameter, and kilometer units I have discussed. Just follow this sequence. 10 mm is equal to 1 centimeter. Okay, next 10 centimeter is equal to 1 decimeter. Okay, next 10 decimeter is equal to 1 meter, and next 10 meter is equal to 1 decameter. Next 5 10 decameter is equal to 1 hectometer. Next 6 10 hectometer is equal to 1 kilometer. Okay, so our question just is 1 kilometer is equal to how much meter. Okay, so 1 kilometer, these two we have to move from this. Okay, so how many tens are used? 10 10 10, so 10 to the power 3 meter. Okay, 1 kilometer. Next question is 1 meter is equal to how much centimeter. Okay, so you have to move from this sorry, this. Okay, so 10 into 10. Okay, that means 10 to the power 2 centimeter, 1 meter. Okay, understand? That's a very important unit you have to remember, or you can follow the sequence where you can easily remember. Okay, next parameter is our number 5, I think. Yes, number 5. L max, that means length of maximum length we can measure, which can be measured, which formula is maximum length required to be measured. And next our parameter which can also derive the L max formula, which is length of scale from LOC. Okay, this is length of scale. We can denote L, which is L equal to RF into L max. Okay, in which we can find the L max by L divided by R, where L is length of scale, that means drawing scale, and L max is the object length. Okay, these are the all 6 parameters. Okay, next we have to remember one thing. When this is RF represented in terms of length, if its area is com, RF can be found divided by root over of drawing area divided by actual area. Okay, and if it is in terms of volume, RF is equal to root cube of drawing area divided by actual area. Okay, this all over the theory portion. Next we have to jump to the what are the scale, as I discussed. Plane scale and diagonal scale are very important, so we next jump to the plane scale. Okay, next our what is the definition of the plane scale? Okay, so plane scale is a scale which shows the relation between two consecutive unit or a single unit or its subdivision. Okay, okay, this is equally divided into 3 parts. Let's this unit will be it will be 3 meter total length. Okay, and each part will be 1 meter, 1 meter, 1 meter. Okay, let's start from this 0, 1 and 2. Okay, this to this 1 meter, this to this 1 meter, this to this 1 meter, and it is further divided into 10 part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is meter, and meter is subdivided into decimeter. Okay, this is decimeter. Okay, and this is the maximum length is called primary scale. Okay, and this is the minor or secondary scale, this first portion. Okay, and if you have to measure the length of the scale, okay, length of the object, let's we have to measure 2.7. Okay, where 2 is meter and 7 is decimeter. Okay, and we have to measure from, this is 1 meter, this is 1 meter, this is 2 meter, this portion to this portion 2 meter, and 2.7, this is 0.567. Okay, this to this is 7. Okay, that's we have to measure from 1.8. Okay, this to this 1 and 0.5678, this is 1.8 meter a decimeter. Okay, this is how we have to measure. Okay, it's all our example. Now we discuss the what is the definition. So plane scale is a scale which show the relation between two consecutive unit or single unit and its subdivision. These are the subdivision. In this scale we have to mention the primary scale, what is the subdivision. Okay, in the example we have mentioned the primary scale division is 3 meter and it is subdivided into decimeter, it's 10 equal part. Okay, write down the definition. Okay, so plane scale is a scale which shows the relation between two consecutive units or single units and its subdivision. Okay, this complete the theory portion of plane scale. Okay, next we have to solve one question. A 1.5 inch line represents a length of 1 foot on the drawing. If this line extended to show 4 foot and a scale is drawn, then determine representative factor, length of scale, primary division, secondary division. Okay, these are the questions. Okay, so our drawing object is given. Okay, read the question first. Okay, a 1.5 inch line represents the length of the 1 foot on the drawing. Okay, if the line extended to show the 4 feet and its scale is drawn that determine the array length of scale, primary division, secondary division. Okay, so given 1.5 inch, then what is the 1.5 inch represent? Okay, this represent the drawing length. Okay, so the drawing length is given 1.5 inch and the actual length is 1 feet. That means the actual object. Okay, so we know representative factor formula is drawing length divided by actual length. Okay, so drawing length given 1.5 inch and the actual length is 1 foot, and 1 foot we know in inch is equal to 12 inch. Okay, so after calculating can get this is 1 by 8. Okay, this is unitless. Okay, and the length of scale, is RF into L max, and this line expanded to show the 4 feet. This is the L max. Okay, 1 by 8 into 4 feet. This is 1 by 2 feet. 1 by 2 into 12 inch. Okay, and 12 inch is equal to 2.25 mm, 25 mm. So after calculating, what is 25 into 6, which is equal to 150 mm. And very important thing is, and we have to the unit of the length of scale will be always mm if it is not given. Okay, very important. Length of scale is formula is RF into L max, and its unit will be mm if it is not given in question. Okay, next we have to draw the scale, and in this case we show the primary division and secondary division. Okay, draw the scale. This will be maximum we can read 4 feet. Okay, and each will be 1 feet, 1 feet, 1 feet. So 4 division will be required. Okay, value we can divide it into 4 part. This is 1 2 3 part. Okay, this is starting from 0 1 2 3, and this 4 part we have to divide it into inches part. Okay, this is all are in feet. 4 feet is max. Okay, and this part we can divide it into inch, and it is 12 part. Okay, equal space 12 part. 1 2 3 4 5 6 7 8 9 10 11 12. Okay, this will be in inch. Okay, this is the primary division, is 4 feet, and this is the secondary division. This is the primary division. Okay, let's complete the example. Okay, next our next scale is diagonal scale. Okay, so diagonal scale we show the relation between three consecutive units, and we know from plane scale we relation between two consecutive unit, or maybe not consecutive, maybe consecutive, maybe not. Okay, and it will be single unit and its subdivision. Okay, and in this case diagonal scale we can relation between three consecutive unit. Its example may be meter, decimeter, centimeter, inch, feet, yard, or 100 meters, 10 meter, and a single unit. Okay, so write down so some points about the diagonal scale. Okay, diagonal scale is a scale which shows the relation between three consecutive units. Okay, so example, meter, decimeter, centimeter. Example 2, 100 meter, 10 meter, and single meter. Okay, these are the example, and now we have to draw the scale and how it will be measured. Okay, so for example, we have to measure a 400-meter scale. Okay, okay, this is the 400-meter scale, and we have to divide it into four equal part. Okay, so this is one part, this is second part, this is third part. Okay, 0, 100, 200, 300. These are equal 100 part, and total is 400. That's unit in meter. Okay, so I have to equal divided into 10 part. Okay, each will be meter, 10 meter, 10 meter. Okay, first unit is 100 part, next 10 meter, 10 meter. Okay, so this portion to this portion we have to divide it into 10 equal part. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. This is not actual, and we have to okay. Next, this vertical line we have to divide it into similar 10 equal parts. Take 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now join this line from this to this. Okay. Next, from parallel to this you can draw. Okay. This is also parallel. Next, this is also parallel to previous one. Next, this is parallel to previous one. Okay. This is parallel to line number 4. Okay. Next, this is parallel to previous one. This is parallel to previous one. Okay. Similarly, we can draw each and every line. These lines are called diagonal. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now join these horizontal lines. Okay. Okay. Now read the how can read this diagonal. Okay. Let's we have to read 257 meter. Okay. So this is 100, this is 100, 200, and we have to read 57. That means 5 decimeter and 7 meter. Okay. This and this are the our this is primary, secondary. Next our secondary 3 consecutive unit. Okay. So these are meter lines and this is decimeter line. Okay. We have to write 257 unit. Okay, meter. So these two these are 200 and these are 50. Okay, decimeter, and I have to make number 7. Okay, this is 7 line and this is our 5 line. This 5 line and this 7 line. Okay. 257 meter. Okay, I hope you understand. The next class I can clearly show what diagonal scale represent. Okay. Okay, these are the diagonal part and I have to divide it into some equal part. Okay. Set the 8 part. Okay, and next we have to divide it into 1, 2, 3, 4 part. Okay, now join the diagonals. 5 parts. Okay. Next, we have to, for better clarify, just draw a single parallel line, diagonal line, so you can understand betterly. Okay, this is 0 and 1, and the diagonal line will be, and we have to divide the diagonal line in 1, 2, 3 part, and it will be project the diagonals. It will equal divided the baseline into 3 part also. Okay. Okay. So okay. So diagonal line easily divided the uh, this projected line into equal parts by dividing this diagonal into equal part. Okay. So these diagonal lines and these diagonal lines are equal, and this diagonal line and this diagonal lines which will parallel to each other, so that we don't need to any joint by previous one. So we simply draw the parallel lines. Okay. And these are the 8 units. That means we can measure up to 8 units, and the diagonal line is divided into 5 parts, so it can subdivide into 5 parts. Okay, 8 divided by 5 parts we can, yeah, that means the least count. Okay, so if you have to measure, suppose we have to measure um, 0.84. Okay, so we have to measure 0.84. This is 0.8, and we have to line 4. Sorry, 0.84 is exceed. Okay, so we have to measure up to 0.8. Okay, maximum length will be 0.8. So when we 0.62 measure. So the question is 0.62 measure. How to measure? Okay, this is 0 and this is 6. This is zero point 0.6 and this is 2. Okay, this is from, we can measure from this line to also. Na? This is 0, 1, 2, 3, 4, 5, 6. Okay, 7, 8. Okay, from this point we have to measure. Okay, 0.62, that means zero point 0.6, and this is 2. Okay, this line 0.62. Okay, this is how we can measure our diagonal scale used to measure 3 consecutive units in the scales. Let's say this is decimeter and this is meter, and we can extend from this to we can measure meter. Okay, diagonal scale is used to for in this plate scale we can't divide as the 3 consecutive numbers into a simple scale, and we can simply uh, draw a diagonal, so we can easily divide it into sub part, so that we can measure up to three accuracy techniques, three consecutive numbers. Okay, this completes scale chapter. Okay, next chapter is our conic section. Okay, so in this chapter our objective is to the conic section may be ellipse, parabola, or and hyperbola play an important role in both mathematics and the application of mathematics to engineering. Okay, the main objective of this chapter to deal the construction of various type of curves such as ellipse, parabola, hyperbola. Okay, mainly deals with parabola, ellipse, and hyperbola. Okay, uh, these curves, that means this ellipse, parabola, hyperbola, these curves are mainly um, very oftenly used in engineering practice. Many engineering structures such as arches, bridges, and dams, mountains, cooling towers. Okay, cooling towers. These are hyperbola. Okay, and this is conical type of chimney. Okay, okay, chimney, roof, stadium, etc. There is involved in this condensation. Okay, it is therefore very much necessary to study the nature of this curve together with some of their geometric property and explain some convenient method for construction of this curve. Okay. Next, our conic section. Okay, conic section is essentially a class of curve which is obtained by a double cone intersected by a plane angle related to the axis of double cone. Okay, how much the angle will be got to the double section cone, so we can get ellipse, parabola, and hyperbola. Okay, these are the introduction class. So in the next class, we deeply or analyze its curve, first ellipse, next parabola and hyperbola, and what are the formula and how it will be derived from the cone. Okay, these are the introduction. Okay, okay, thank you. And next class we see conic section and types and how the ellipse, parabola, and hyperbola will be formed from the double cone section and what are the formula related to this conic section and how to draw. Okay, so thank you.